Welcome everyone. In this lesson, we're going to be looking at properties of the natural log function. And really these properties are going to work for any of the log functions that we would normally consider, but we're going to be primarily just focused on natural log. All right, so let's just look at these properties. And ultimately, we're going to see how we can use these to help us with differentiation. But for now, let's just kind of read through the properties here. So we're going to suppose x and y are just positive numbers, and later on, b can be any number. So the first property here says that the natural log of x times y is equal to the natural log of x plus the natural log of y. And what this property does is essentially it takes, if we have multiplication going on inside of our log function, which we see right here, we have two terms, x and y, two numbers, x and y getting multiplied together. Well, that multiplication essentially gets converted into addition outside of the natural log. So essentially we take each term here, break it apart, and then we add those log terms together. So the multiplication gets converted into addition. And then the same kind of deal happens with division. So if we have division going on inside of our log function, which we have right here. So for this next property, we have x divided by y inside the log function. And what this property tells us is that this is equal to the natural log of the top term minus the natural log of the bottom term. So essentially, if we have division going on inside of our log function, well, that gets converted into subtraction outside of our log function. And kind of a special case of this is if we have 1 over x inside a log function. So if we have a reciprocal, well, then it becomes negative natural log x. So this tells us what happens with reciprocals. And then the last one, and this third one, this is really just a special case of the first one here. And it might be helpful to remember that the natural log of 1 is equal to 0. Then you can kind of see why that property works out. And then the last one, this last one tells us what to do with exponents. So if we have a number getting raised to a power, so x raised to the power b, inside of the log function, well, we can take the exponent and we can bring it out in front of the natural log. So this one tells us what to do when we have exponents. All right, so when we're looking through this list, it's going to be important to remember that these properties only tell us what's going on, only allow us to do anything if we have multiplication, division, well, division, both of these are division, or exponents inside of our log function. So there is no rule to simplify things like natural log of x plus y or natural log of x minus y. So if we have addition going on inside the natural log, or if we have subtraction going on inside the natural log, we kind of get stuck. There's not much we can do to simplify that. So these properties only work if it's multiplication, division, or exponents inside of the log function. Or we're probably going to be actually, well, yeah, we'll be using these in both directions. So you want to also just think, if we have two log functions being added together, well, sometimes it's going to be helpful to kind of combine those into one log function or one log term. So you can kind of use these properties in both directions. And these properties really come from our exponent laws. So just to kind of briefly talk about this. each of these log properties comes from an exponent law. So for this first one, natural log x plus natural log y. This one comes from the exponent law. When we have two exponential terms, e to the x times e to the y, what do? We add the exponents together. And that's precisely what this is telling us. We add, if we think of natural log x and natural log y as kind of just fancy exponents, we just add the exponents. For the fraction one, if we have e to the x over e to the y, well, we subtract the exponents. So that was our exponent law that we've seen before, and that's precisely what we're seeing. Again, think of natural log x and natural log y as just fancy exponents, and we're just subtracting them. Or if we have this reciprocal with the negative in front, we've seen this thing as well. So if we have 1 over, say, e to the x, well, the usual thing we would do is just get rid of the fraction and make the exponent negative. And again, that's what it's telling us. Make the exponent negative. Or for the last one, the exponent property was if we had e to the x and then that whole thing raised to the power b, well, we would multiply the exponents together. So we'd get e to the b times x. And that's what we're seeing. B times a fancy exponent. All right, so let's see how to actually use these properties, these log properties. So let's look at example 1. We're going to simplify the expression natural log 5 plus 2 times natural log 3 using all of these log properties that we've seen. And when we do this, we want to kind of be systematic about it. And the first thing we have to do is we have to deal with any constant multiples in our expression. So these are numbers in front of natural log. All right, so we have to do something with those first. And when we kind of scan through our expression here, this natural log 5 term, good. There's really no number. It's a hidden 1, but it's just a single log term. The issue comes with this second part here, and we have this 2 in front, this constant multiple 2. We have to do something with that. And what we do is we use property 4 on our list here. And it's not so important that you have these memorized in order or anything, but we want to use this property. And so what we're going to do is we're going to take this constant multiple, this number in front of our log term, and it's going to become an exponent inside the log function. So let's see how this is going to work. So natural log 5, we're not going to do anything with that. But then this 2, we're going to bring it on inside, and it's going to become an exponent on that 3. So we're going to have natural log of 3 squared. And as soon as you start bringing things inside of the log function, I think it's helpful to kind of throw some parentheses around it. All right, so once we've dealt with all the constant multiples, then the next thing we want to do, kind of step 2, is we want to combine the log terms that are separated by either addition or subtraction. And for those, we would use either property 1 or property 2. So property 1 says if we have something separated by addition, essentially we can convert that into one log term where we just multiply those pieces from inside each of the individual logs. So that's what we're going to use here because we have one log term plus another log term. And so we're going to take the 5, we're going to take the 3 squared and multiply those together. And those will become our new single log expression. And then if we kind of keep going, well, we could multiply the numbers, and that would do it. Natural log of what? 5 times 9, 45. All right, so just a little practice there. Let's try another one, just to get used to these log expressions. So let's look at example 2. And for this one, we have 1/2 times natural log of 4t minus natural log of t squared plus 1. And what we want to do is we want to write this as a single logarithm. So essentially, we want to combine all of this into just one log term. All right, so let's see what we can do. And so the first step is we got to do something. We want to look at each log term that we have. And any constant multiple, we have to deal with that first. So this 1/2, we got to do something about it. And so the way we deal with our constant multiples is we go up to this exponent property that says if you have a number in front of the natural log, you bring it on inside, and it becomes kind of an exponent on whatever you had in there to begin with. So we're going to take this 1/2, we're going to bring it on inside, and it's going to become the exponent on 4t. So we're going to have natural log 4t, and that 4t, everything is getting raised to the 1/2 power. All right. And we need the parentheses around the 4 and the t because everything has to get raised to the 1/2 there. All right. So that's our first step. And then we have subtraction. And then the second log term was good. There was no constant multiple in front. All right. So now we want to get these combined even further. And we see that they're separated by a subtraction sign. So what happens with subtraction, if we go back up to our properties, so if we have 2 log terms and we're subtracting, well, we can convert that into a single log where we have a fraction. And we take the first piece, that becomes the numerator, and we take the second piece, that becomes the denominator. All right, so if we go back down, our first piece here, this is going to be the numerator once we apply the property. And then the second piece, the t squared plus 1 that's in there, that's going to become our denominator once we get this as a single log term. So let's do it. We're going to have 1 natural log, and then let's get a nice big set of parentheses here for our fraction that's going to come. And we're going to have our 4t raised to the 1/2 divided by t squared plus 1. And there's our single log expression. We could go maybe a little bit further if we wanted to, and we could kind of use our regular exponent rules to break this apart even further. So we could take the 1/2 and distribute it to the 4. So square root of 4 is just 2, and then we'd have t raised to the 1/2. So if we wanted to, we could maybe simplify this just a little bit using some exponent rules. So the square root of 4 is 2, and then we'd have t raised to the 1/2. And then at this point, we wouldn't need parentheses around the terms in the numerator there because only the t now is getting raised to the 1/2. We've kind of simplified that 4. All right, so that's the idea. Sometimes it's helpful if we have multiple log terms in an expression, try to clean it up into one single log expression. Well, let's try one more. What happens if we have multiple log terms? Well, we can just kind of keep repeating the process. And so you can just go down the road here, or down the line here. So let's kind of look. We have this, in example 3, we have this expression natural log x plus natural log 3 plus natural log y minus the natural log of 5. So first thing, we want to look for any constant multiples. So I don't see anything here, 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 or here. So we're good. Constant multiples aren't an issue. And then from there, I see an addition sign here, and then subtraction. So we can just kind of work our way right down. So let's combine these two together. So we get natural log of x times 3. And then we have our plus natural log y minus natural log 5. And then once we have those two combined, well, we have now an addition sign here, so we can combine these two. So we end up with natural log of x times 3 times y. So basically I'm taking the x times 3 from here, and then I'm multiplying it with the y. And then we have just one single log. And then I'm still subtracting the natural log 5. And now we have subtraction. So that means we're going to end up with a fraction here. So I can take we're going to get one log term. And I can take the pieces from inside the first one. Those are going to become my numerator. And then I can take the piece from inside the second one, the 5, and that's going to become my denominator. So we end up with natural log of x times 3 times y all over 5. And if I wanted to, probably I could have done this way earlier, but we could just rewrite this as natural log 3xy over 5. All right, so we can just kind of repeat this process as much as we need. Use these properties as much as you can until, in this case, we got it down to a single log expression. Now, why these properties are helpful is we can kind of use them to help us differentiate more complicated functions. And that's what we're going to see in example 4. So we're going to actually put some of these log properties to use. We're going to differentiate this log function, natural log of x times x plus 1 times x plus 2. And if we were going to do this, now there's a few ways to do this. So the first way is just use our general log rule that we've looked at. Kind of like chain rule. So we have the natural log and then a whole bunch of stuff going on inside that natural log. So one way to get the derivative is to first do the reciprocal of everything inside. So 1 over x times x plus 1 times x plus 2. And then multiply by the derivative of everything that was inside the natural log. Perfectly fine. You could definitely do it that way. The only issue is to differentiate this, you have to be careful because as it's written, you'd have to use product rule twice. So that might be kind of complicated. So instead, another option is simplify the natural log terms first using our log properties. And so if we look at this, what's going on inside this log function? Well, we have some multiplication. So we have x times x plus 1, and then x plus 1 times x plus 2. So we have a couple different multiplications going on in here. And why natural log is so nice is we can essentially break up these, wherever we have multiplication going on inside of our natural log, we can split it up into, in this case, 3 separate natural log terms. And that's because of this property right here. If we have multiplication going on inside of the log expression, well, we can break it up. Take the first part, it gets its own natural log. Take the second part, it gets its own natural log. And then that multiplication essentially gets kind of converted into addition. And so what we end up with here is we can just rewrite we can simplify this down. And we're going to split this up into 3 separate log terms. We're going to have natural log of the first one plus natural log of the second factor, so natural log of x plus 1, plus the natural log of the third factor, so x plus 2. And then from here, now differentiating is not too bad. So now we can differentiate. And first, differentiate the first natural log, gives us 1 over x. Differentiate the second natural log. We still have to use our general log rule here, but it's not too bad. We end up with 1 over the x plus 1 times the derivative of x plus 1. And then same thing. We have to differentiate this last one. So we end up with 1 over x plus 2. So again, general log rule, what does it do? You take what's inside the log term, you do its reciprocal, and then you multiply by what was inside the log. So in this case, the x plus 2. And these remaining derivatives are both 1. So in this case, we end up with y prime is equal to 1 over x plus 1 over x plus 1 plus 1 over x plus 2. And so this is why kind of using those log properties can be helpful for more complicated derivatives, because once we convert that multiplication into addition or subtraction, the differentiation process is much easier when we have addition and subtraction signs, because we can just focus in on differentiating each of those individual terms on their own. It's when we have multiplication and division, that's when things get complicated, because we have to use our product and quotient rules. All right, so we're going to try another example like this in class. So we'll see you then. Bye-bye.